Hi, my name is Pablo Galindo.
And my name is Łukasz Langa.
And this is the core.py podcast. Even if you think we were gone, we are here. We are an established podcast where we discuss the internals of CPython and our adventures in making a new version of your favorite programming language. What happened, Łukasz? What happened with us?
Well, we did want to record an episode after EuroPython, but that ended up being very intense. We're going to talk about this today.
Yes, but it's all Łuka's fault. It's all Łuka's fault. I was ready to record this podcast, but he was not here. My dear audience, he was not here. It was his fault.
Yeah, I was out all August. First, I went to Japan, where it was extremely nice, but extremely humid and hot. And then we went to PyCon Poland. We're going to talk about this a little as well today.
Yes. And even before that, we were in EuroPython, right?
Yes. So after EuroPython, we wanted to give you a summary. So we'll do this now, even though it's already September, and we are very close to releasing 3.13 release candidate 2. We're going to talk about this as well.
And why is not really a release candidate 2?
Yeah, we can share the secrets with you as well.
Secrets.
All right. So let's start at the very beginning. EuroPython happened in Prague again, just as in 2023. Both of us had talks, and we attended talks by others.
We were on a boat.
Oh, yeah. Actually, we went on a boat. And Antonio Cuni made me record a message to Carl Friedrich Boltz about
one of the maintainers of PyPy, in case you don't know who he is.
Yes, about how we should maintain pyrepl going forward. Since, as you might remember, we originally took pyrepl from PyPy and then changed everything.
And now it's different. Now it's CPython's pyrepl.
Right, yes. So
No. It's only one pyrepl. We didn't smuggle it. It's it was all agreed. But PyPy has its own version. Actually, right now there is two versions, right? Because but before it was three versions, right? One of them it was the one in PyPy. Man, this is going to be very difficult to explain for someone who has no fucking idea. So there is the version in PyPI, the Python packaging index, which is like pyrepl, which is under PyPy GitHub account, because the PyPy, the interpreter, not the PyPI, Python packaging index. So those they have a GitHub account, and in the GitHub account you can find a bunch of other things apart from PyPy, and they have pyrepl. But then there is another one in PyPy itself, which is the one that we took initially, and then now there is one in CPython. So there were three. But Antonio Cuni didn't like those three, right, Łukasz?
Right. I mean, it would be perfect if we just had one pyrepl to maintain. And since we started making extensive modifications to pyrepl, my idea, which Carl Friedrich Boltz shared, was that maybe now PyPy should do the reverse thing and take pyrepl from us. And now we have a single version that we're going to be maintaining together, essentially. And that's already happening, it seems.
Yes, actually, Carl made a bunch of PRs to fix some inconsistencies between CPython and PyPy. Particularly, I think one of them was... actually, he apart from fixing these inconsistencies, he also contributed a bunch of things related. For instance, I don't know how it's related. I think it's because there is some configuration over how many frames pyrepl displays when there is an error, and you can configure that via sys.traceback frames or something like that. But then there is the traceback module, and the traceback module has something like n frames or something. There is another way to limit those, and it's super confusing because one takes a positive number, but the other is a negative number in the subversion of the two that you cannot reproduce. So he kind of documented that, and he fixed all those inconsistencies. So if I understand correctly, PyPy right now is using our version of the REPL, right?
Yeah.
Carl, reach out to correct us.
Our version. We made this.
We made this. Yes.
Yeah, but the spirit of collaboration is actually pretty awesome. We essentially accelerated both of our projects that way, since we are extremely grateful for what what PyPy provided to us, but we provided also features back, right? Like this entire Windows support was not a thing that PyPy previously had, and now they do.
Well, not only Windows support, we provided like wide Unicode support. So like for instance, for Chinese character and emojis,
Pink colors,
synthwave colors.
synthwave colors.
Yeah, so
Amazing.
color output, Unicode support, paste mode. We fix a ton of weird bugs with like Control C and like the buffers.
Yeah, and what happens when you actually reach the end of the width of a narrow terminal on Apple terminal and stuff?
Spoiler.
Right. We're gonna be talking about this, but we're drifting away.
Yes.
From the event, right? Like we went to EuroPython.
EuroPython, yes.
So we gave our own talks, but before we got to those and, essentially toot our own horn, let's give a shout out to a talk that I very much enjoyed. So there was a keynote on the same day as mine, only at the start of the day, which was called Healthy Teams for Healthy Code Bases by Mai Giménez, who is a Señorita research engineer at the DeepMind.
This is just before my kills us. This is an internal joke, actually. Well, no, I don't know if it's internal, but like wow, do you want to explain this? Well, yeah, let's go. So this is a shout out of like senior, senior engineer or whatever in Spanish, right? Because you will say senior really bad.
Yeah. So back in the day when I worked at Facebook, the levels, at least then, of employees were not publicized, and certain people really pushed for those levels to be public. So some of us started calling ourselves senior engineer, just so that like we essentially ridiculed the idea to appear more senior than others.
Right.
So Mai Giménez, Señorita research engineer at DeepMind, working on Gemini. But like I think she will not kill us, because she started with this self-deprecating comment that she is going to prove to us that she is not this tiny weirdo who hates things. That's a direct quote. She said
that.
Yeah. But and later on, like, she did. So I believe it, because the talk had like everything, like how a good code base starts with, open-minded people, humble enough to try new things, and why we code. So that was sort of inspiring. Like, we code because we are committed to a purpose. And that's like, well, okay, that really kind of brings this into perspective. But what really touched my heart, like my stone heart, was that among all the things that the topic covered, which was like good fits for the team, like how Python has gotchas because it's dynamic, how you need to think about logistics, block time for the research phase, create some alternative space like hackathons to inspire creativity, like suddenly was like, boom, there's Python typing on the slides. And I'm seeing type annotations. I'm like, oh.
The typing mafia.
Yes. My esteemed typing. I very much like to see this.
Oh man, you don't know how much my esteemed typing. Like sometimes she sends me these like questions. It's like, hey Pablo, what do you think about this? And it's this like mega puzzle with typing. Like it's like data classes that are at the same time interfaces but implement like typing or something, but it has descriptors. I'm like, wow.
Yeah, it was very impressive on the keynote how like, Jack's typing with, the complexities of data science typing is something that many people that were originally involved in adding static typing to Python didn't really anticipate going off that well. And it did. And, stuff like runtime type checking is entirely sort of, maybe outside of the radar of people that are interested in MyPy and so on. So all of those things, fascinating. So I very much recommend you watch this talk when it becomes available on YouTube. I did enjoy that at EuroPython. What else will we do?
Well, I enjoy another one I would like to highlight. So this is a talk by Yuliia Barabash and Laysa Uchoa. I'm very sorry if I'm butchering the names, but this was an introduction to Python memory management. So it was quite clear because like normally you see these talks like from once in a while, and this is a topic that feels very close to my heart because like I've been working a lot here and I've been developing like memory and whatnot. So what normally happens in these talks, which is good, like don't get me wrong, like they're very introductory to like reference count and like garbage collection and whatnot. But they normally are like very like showing the surface of this, right? And the other challenges you have is that you want to be a bit deeper. Then you need to like it's very complicated because these topics are so big that you will need to spend more than just half an hour. But this talk in particular, apart from having like a very beautiful slides, I really enjoyed the theme and it was like quite cohesive. They touch mostly everything. They touch like the memory model, the object model, sorry, the like the reference counting, the garbage collector. Like I mean, all these talks close the garbage collector a bit because like that's a talk that will take the whole time. But it was surprisingly like a lot of information about like how it works and generations and whatnot. So I think they did an excellent job in a topic that is not very easy.
Very cool.
I enjoyed it quite a lot.
All right. So another recommendation once the talks become available on YouTube. We also took part in the core developer panel with Carol Willing, Victor Stinner, Hugo Petter, and answered questions for what was it, like an hour?
Yeah, something like that.
Yeah,
I don't know how the people survive that hour.
it went fast for us. Like this is what I can tell you. In fact, like Hugo and Peter did help us tremendously after the conference when we held sprints that many projects did after EuroPython, and the particular one for CPYTHON got the biggest room, and we essentially had it full on Saturday and mostly full on Sunday. So like we were very kind of overwhelmed by interest. So that was very cool to see.
Yeah, that's very nice.
Right. So what was your talk about, Pablo?
Oh, my talk was about like it was called Tales from the Abyss, and basically the talk was about like a bunch of like weird errors that we have seen in while developing Python. And basically, it's basically like a all person war stories about like how annoying it is to develop CPython. And basically, I think it's a 45-minute discussion about why C99 is a really bad language. But yeah, like I talk about a bunch of them. Like if you want, like we can mention some of these errors. So for instance, I think one of my favorite ones is an error that we saw when we were developing the new parser. And this is like we all have like everything ready, like a gigantic PR. It's the first version of the parser that I need to enter in one way, like superseding the old one. And we were like because we are responsible people, we tried the build first before merging, just to ensure that it works. I mean, the parser doesn't have anything platform dependent, it's not like reading bytes is different in different architectures. Spoiler, it is.
Right.
Right. And then we saw this like normally when something crashes in a different platform, what happens is that it just like sec faults or something like that. It's like invalid call or whatever. But in this particular case, it was like a very stupid like invalid string or something. Valid string, and the error is it was a syntax error that was only appearing in AR64.
Whoa.
Yeah. So I think it was the Raspberry Pi based Billbot, and it's just like, yes, in this platform, this string is a syntax error, and like that was quite weird. And if you try to touch it like slightly, I don't know if you know it, but like there is this macro in CPython called PyUnreachable. Do you know what happens if you call PyUnreachable?
You get like a very cheeky error message.
Well, more than very cheeky. It literally is an XKCD comic reference saying something like, "We have reached an unreachable state. Anything is possible. The limits were in your head all along. Follow your dreams." And it says like, segfault. So there is a bunch of functions that basically return tokens, right? And tokens in the tokenizer are represented by integers, right? Because like we cannot use strings to say left parentheses, so it's like an enum. Because like these integers, we don't need the full range of integers. We're using chars or chars, in C. And some functions return these things. And you know what? Like these functions can also fail. And you know what we were returning if the function fails?
I don't know.
-1.
-1.
-1. Yeah, -1. So problem. What is the problem? Well, it turns out that if you look at the C11 standard, the C11 standard says the C standard does not define whether char is a signed or unsigned type. Fuck you. There is more text, but I just simplified it. I just simplified the test. So basically, the C11 standard says, well, I mean, this type can be either like, signed or unsigned, and sometimes it's one, sometimes it's other. Figure it out. And in particular, normally is unsigned. Is signed, which means that -1 is -1, right? And you can use yes, and you can use half the range for positive numbers, half the range for negative numbers, and everything is good. But in ARM, in this particular platform, ARM AR64, then it was unsigned, which means that -1 becomes
255.
Exactly. And you know what also is 255? Is another token. In this particular, it was the left bracket or something. And then, that -1 transforms itself into left bracket, and the token and the parser was saying like, what is this left bracket business?
Yeah, it's unexpected.
Unexpected syntax error. And it's like, left bracket, incorrect left bracket. And it's like, what is the left bracket, motherfucker? Like, there's no left bracket and a syntax error. And that took a fucking ton of time to just find out because, like, it's bad. So, the summary here is like, don't use C. Like, C is bad because C is
the illegal language.
By the way, many people mentioned that in my talk I mistype illegal with only one L, so I say the illegal language or something like that.
Yeah.
So double illegal.
Yes,
that's illegal.
That's
it's illegal to say illegal.
Yeah, literally.
Yes. One of my other favorite ones, I'm not going to mention all of the ones in the talk, but like another favorite one of mine is this bug that we receive. I think I mentioned it at some point in the podcast, maybe, so I will be fast here. Is this bug that we received that you have a file, right? And then you raise an exception.
Yeah.
And the exception, let's say you catch it or whatever, like doesn't matter what happens, but you raise an exception and you measure the time it takes to raise the exception, right? Let's say it's, I don't know, 1 microsecond or whatever it is. That's too much, but like it's an example. And then that exception is raised on line 100. And then if you, instead of line 100, you raise the exception in the same function, but in line 600, then it takes like exponentially more time to raise it in like 600 than in line 100. Insane. How is this possible?
We talked about this.
Yes. So the reason is because we have a table that basically because we add to the exception the line number and we only know the instruction at the time the exception is raised. And then we have a table that basically translates the instruction number into the line number, and that table it needs to be decoded because it's compressed. And compressing the instruction in line 600 is, you need to decode all the previous ones. So you need to wait until you decode the rest.
Yeah.
So now what we do, Łukasz, do you remember what we do? You don't remember. You're like, error. Łukasz doesn't remember. Yeah. So you say, we talk about this, Pablo, we talk about this, but you don't remember.
No.
So we only do it lazily. So now the line number object in the exceptions, TB line is a property, like it's a descriptor, and then we only calculate if you ask for it.
If you ask
yes,
for
not when we raise it, because if you just raise it and then you capture it, then it doesn't really matter. So yeah, very fun. Do you want to hear more, or do you want to move to something else, Łukasz?
So let's say, okay, there was the segmentation fault happening only after May 6th. The explanation is a little disappointing. So let's leave people
I'm
to see this themselves.
Okay, yes. Please reach out and mention if this explanation is disappointed, because I am disappointed that people find this disappointing. Okay, like actually Yuri was really hard with me. He's like, this is disappointing.
Yeah.
Do you also think it's disappointing?
Right.
Okay, I will tell this, and you, dear listeners, you tell me what you think.
Okay.
So this is the thing, right? So Pablo was at Bloomberg, and we were like, we maintain a lot of Python code and whatnot. And then after a particular date, I think it's like the 6th of May, or the 7th of May, I think it was, of 2022, boom, everything starts crashing in Python 3.6, only in Python 3.6. So at Bloomberg, we have all Python versions. You can choose whatever you want. And all the Python 3.6 packages were blowing up. And we're seg faulting, so just hard crashing on like some random setup.pys. So like not really like doing anything weird in C extension. It's just almost when you install the package, kaboom, it just blows up.
Right.
Only after this particular date. Before, it was fine. So no changes, right? Like we didn't change anything. Python 3.6 is like mega dead. Like nothing has been resurrected there, and like the packages have not changed for Python 3.6. So looking at this a bit more, we discovered that these setup.pys that were like segfaulting were only the ones that were importing C types. So not doing anything fancy because you say, Pablo, claro, of course, like, C types, that's evil. No. Not doing anything weird, just importing C types. Well, spoiler, turns out that importing C types already does some funky weird shit. In particular, there is this function called reset cache that does a bunch of like C shenanigans. But those C shenanigans, which is basically like registering a lambda and calling a lambda, just seg faults. And it turns out that you look at it a bit like, in GDB, you need to touch a debugger because now it's C code that you're dealing with. It turns out that this was initializing an object, in particular a cfunc pointer object, like it's the C types wrapper for C functions, right? And it was segfaulting, assigning a variable inside the structure. So basically, like, thunk, I think it was called, or whatever. And how can something segfault assigning a variable, right? So if we spent a lot of time like looking at the screen like idiots, and then at some point I decided to look for reason at the disassembles, and then we saw that actually the segfault happens on an AVX instructions. Oh no, AVX instructions, those are evil because those are vectorized instructions. And turns out that vectorized instructions are these super cool instructions that have fancy names like mobups. This was mobups actually, and mobups have like this alignment requirement, which means that you cannot just mobups into something shit. Like if you look at this, like the actual text is super annoying because it's like there is the source operand and the destination operand, and like it needs to be aligned to a 16-byte boundary, like blah 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 blah. Like it's very annoying. And it depends if it's EVX 512 or whatever. So boring. It turns out that mobups and its bigger brother vmoboops. These fucking instructions. So these instructions, you cannot just use them with a random pointer. That pointer needs to align to a specific boundary. In this case, I think it's 16 bytes. And guess what? It wasn't. It wasn't. So it wasn't because at the time Python 3.6 the Python memory allocator didn't return memory segments aligned to 16 bytes. So it's kind of like it's the fault of the memory allocator. But why was not this happening before this mysterious date? Why only after this date? Łukasz, do you remember the reason?
Yeah, because the compiler changed.
Because on that particular day GCC 12 was released. And then because you were compiling the same code with DCC 12 says, this assignment looks boring. It will be much more salty if we use these bmoops. Now bmoops was not ready for the party, and blows up. So boring. Compiler change things, but like the kind of way to see the problem was like random setup.py executing. Like can you imagine giving this back to some intern? Like imagine that some intern joins the team, like happiness on their face, they're happy and like they love life and they're super excited, and then you say, hey look, running this setup.py on Python 3.6 segfaults. Why don't you look at it?
Right, but like for me the disappointment just stems from the fact that just after a date you just happen to install a new compiler, so because of the new compiler the behavior is different. The fact that the new compiler learned to now vectorize, like that's all interesting, cool, yes, but the actual implementation of the function that this is May 7th of 2022 is that was the date where you got the new compiler, right?
It's the date that it was released the previous day. So I mean, but think about it. Like you could say, but it's the fault of the compiler. No, the fault is the fault of PyMalloc. Remember, PyMalloc had a bug that was not returning pointer aligned to 16 bytes, right? So that was the bug. Another question is you're a random CPython contributor, and your thing segfault is your fault. Like let's say the compiler is not at fault here. And let's say what happens here is that you see it because your distro happened to upgrade the compiler. Like you never look at this. Like who looks at the actual version of the package when they update the distro? Like whatever, right? Like it's just new thing, like free shit, like done. Yeah, give it to me. And then it bloop, it segfault. It is a real thing. Like it will happen on a billboard. Like those billboards are constantly being updated. So suddenly Bob is segfault and you didn't change anything. And it's a real bug. So the interesting part in this particular story which you will say, oh, the date, I'm sure it's Paul Gansel's fault because it's like same date and stuff, right? No, this time it was not Paul Gansel's fault. But it's just the compiler.
But just this time.
Just this time, yeah. Any other time is Paul Gansel's fault.
All I'm saying is when you're saying syntax errors that only happen on AArch64, that was accurate. When you're saying slow exception depending on the number of the line, that was entirely accurate. And when you say segmentation faults only after May 7th, 2022, well, that description is a little bit misleading because it's not about the date. The date is not the function
but
there.
guess what, man? Like storytellers lie, you know?
I would never.
You will never lie.
I would never.
It's because you're not a storyteller.
Am I not? No.
You're a musician, which is worse. I'm also a musician.
All right. Is there anything that you're not? Like also a magician and a physicist?
Man, do you know that there is a famous video? Well, okay, this is no, I didn't say anything. Like there is someone who was called a musician, and she was like, no. You mean like why you call me a magician? No, musician. Like no, you're calling me magician. Like no, but you. I make music. I'm not a magician. It's in Twitter. Look at it. It's a bit controversial. So you've been warned.
Yeah. So since we're already kind of pivoting to that music thing, my talk was.
By the way, just as interruption. So just for everyone to know. Sorry, Łukasz, I'm going to betray you. So we have a. I mean, you probably know already. We have this Google Doc when we have all the topics that we will be talking, and this section is called "Stuff from Łukašito," which in Spanish means small Łukasz.
Yes.
Łukašito.
And for you to know, Pablo is not Pablito because
Pabluco.
Pablito is it's Pabluco because he is from a region of Spain where people would say Pabluco.
Right.
All right. So yeah, but the section was not called that.
No. Because I wrote it.
Yes, because Pablo wrote it himself. So yeah, obviously.
Right.
In any case, my particular talk closed the conference. So that was the closing keynote. And I wanted to do everything. Like since I had just one talk, I wanted it to cover what we were working on with Python, so pyrepl. I wanted to give a shout out to Sam Groves and his work on free threading. I wanted to do some music in there, and I wanted to be Dave Beasley, if only for a short while. If only just a little bit.
45 minutes of the
video. So what I did was live coding music with pyrepl. I brought a ton of hardware, which I didn't properly explain. There was no time. So some of the things that were there weren't entirely obvious. So we might actually get to...
This was my reaction when Łukasz told me all the stuff that he was going to bring and all the things that he was going to do. Of course no, because he fails, man. You don't bring things to the stage. He had an entire automobile automation plant on the stage with tons of buttons, and every single button can fail. Why would you do this, Łukasz?
Almost everything worked. Worked.
Mostly, yes.
Yeah. So the thing that some attendees even didn't, I think, quite get was that what I was actually showing was a free-threaded version of Python running 64 threads, actually truly in parallel, and with some synchronization primitives that we have in threading. And I was just, all singing, all dancing, and something that is impossible with a Python that has the GIL, because that all synchronization and real-time performance will just take too much time, and the GIL will interrupt in times that are kind of bad for just listening to the music. It will not appear as if it's in time.
Man, let me highlight this because this is the best illustration of the problem of the GIL and the value of the free threaded version ever. He had this collection of paths that I'm seeing right now, because surprise, we are recording this from Łukasz's office. We are not in two different places right now. So if you have this path, you can imagine this, dear listener, as a square with a lot of tiny squares. I think it's I don't know, 8 by 8
8 by 8,
yes. Right? And then like they do like a bunch of patterns. And if you have the GIL activated, then because every of those tiny squares is controlled by a thread, those patterns are not updated in parallel. So only one pattern is turning on and off at the same time. And therefore, if you're trying to do some kind of like nice thing, like when you turn them on all off at the same time, or you draw some stuff, it looks like shit because like they don't do like there is delay, there is lag, it's really bad. And then you switch to the like the free threaded version, and it looks fucking fantastic, like sharp as like something very sharp.
Yeah.
So
it stays in time.
Yes, but what did you do, Łukasz? He had a dedicated camera looking at this thing. So from the stage, so from the audience, sorry, you could look at like at Łukasz, and in the thing that was being projected, you could see him, and you could see the camera that was showing to this particular like device, and you could see all this thing happening with colors and all sorts of bullshit. And what do you do?
Well, because of some debugging of live coding, I showed Ableton Live for a split second that I needed it. And then I never actually showed the camera again.
To switch it so it was not in the screen.
Yes.
The best possible like representation lost forever.
Yeah, so I'm gonna have to like record a video just to show like this sort of
What
thing
a
clear.
loser.
Since we did manage to show some things just about pyrepl, right?
Oh,
so
yeah.
Like
That was very impressive.
imagine this. There is Python, and now it has the interactive shell written in Python. So it is entirely feasible to launch Python, the REPL, and type in commands that change the behavior of the REPL that you are in, that you are currently using. And we did have some preparation beforehand so that the REPL, the Python that I had allowed for sharp and flat signs in identifiers.
Man, that was very, very funny. So we were in the hotel room, right? And or we just arrived at the hotel. We were in the same hotel, and Łukasz is like, oh, man, like I'm practicing this talk. I'm like you know like shaking like someone who has drink like too much coffee. Like like I need to do the thing. I need to do the thing. I don't have time. Like can you make me a patch that like makes this like sharp and like flat symbols in Unicode work, because like surprise in Python those symbols are illegal, right?
Yeah, they're in the wrong category of characters.
You cannot say C# and use the sharp like Unicode character, because Python tells you like no. And like he's like, okay, do the patch. And then I did the patch, and I told him, and I was like, all right, because like you want to use them in the talk, because like it's more clear that you're using C# and not like C4 or whatever it is. And I suggested to Łukasz that he should start with the symbols not working. And then he should switch them on by using an environment variable called like parser subscription level premium or platinum.
Yes.
And then only when you set that environment variable, then it works. And I thought he was doing that, but like he had something better.
Yeah, I had something else, which is in the REPL you can have commands, and one of the super popular commands with users already is exit. You can just say exit and it exits. It's amazing.
Exit, wow.
Yes. But like now I added a command called IDDQD, like in classic Doom. And it showed an image of Pablo with laser eyes. Yes, exactly. So Pabluko with laser eyes, and also enabled the C# like and flat characters in identifiers. But obviously those characters are sort of weird Unicode, so you cannot really type them easily. So in real time on stage, I typed in a modification to pyrepl that was currently running, where every time that I typed in hash, which is the comment character in Python, it would replace it with a sharp character. So it actually worked. I could just type very quickly. So people like that. I like that as well. And I live coded a ton of like sequencing and so on. So I had to say self dot a lot. So another thing that I coded like on stage was this auto self command to pyrepl, which was a shortcut. So instead of saying self dot, you could just press Ctrl S and it just auto-completed self dot for me. So the entire point was to show like, hey, the REPL is hackable now. Like obviously we don't expect people to hack it really when they are using it. But what that means is if you have Python startup, you can feasibly just hook into pyrepl then and just make changes to it, because why not? It's not like a core developer recommended this because this is not a API that you should be depending on. But like, hey,
Illegal with 2 L's.
yeah, but there's this consenting adults principles. Like, if you can find it, you can play with it.
Let me stop you there. Like, no, illegal.
Illegal?
You're suggesting people to depend on pyrepl. Don't depend on pyrepl. Just don't do it. Bad boy.
You don't get me. I'm trying to trick people into becoming contributors to pyrepl.
That's a better thing.
Yeah.
Man, and this has been, we said this, but let me say it again because it's very important. This has been like the best decision ever because nobody wanted, like everybody hated the old REPL because like it's just annoying and you could do all these things and nobody doing it. But like it was in C, the illegal language, and nobody was doing anything. But now, man, we have tons of PRs. Like how many PRs do we have? Like of people contributed to the REPL, all sort of weird shit.
Yeah.
Like we have auto indentation and like people like fixing like shortcuts and like different terminals and people like fixing substring search. Like it's fantastic. Like there is a lot of people, but like a lot. Like we have so many REPL issues and new features that are being suggested. Like it's fantastic, man. Best idea.
Let
ever.
me bring one person. So there's Esther Beltrami, who actually had a lightning talk after my keynote. And it turned out that not only I was interested in making identifiers work for more characters than allowed. So the lightning talk Esther showed was about allowing the, typical Italian gesture to be imported.
Right, she's Italian, right? She was
Yes,
from PyCon Italy.
exactly. So she made that change, right? Like, and showed it in the lightning talk, which was hilarious. And it turns out she is now contributing to Python and to pyrepl in particular. There is a change in flight about history navigation with partial text. That is by Esther. So that's amazing. That's amazing to see that, like, in fact, we are gathering more contributors.
I think you broke a bit her heart because like you did the change. She was not expecting that.
Oh, like in the keynote, but like I didn't.
No, not in the PR, not in the PR.
Yeah, because I didn't know about like what lightning talks are gonna come up later. So I'm saying like it shouldn't really be construed as like, oh, I just like showed the same thing sooner and so on. Like it's not a race, right? Like it is quite amazing because of course she had this ready before. That like two people came up with the same idea independently essentially. And the change in flight, mostly ready. I think it's just mostly waiting for us to like drive it with Esther and land it for 3.14 at this point. Like 3.13 is pretty much set in stone. As we said before, release candidate 2 is coming on Tuesday, so very soon.
Right. A bit illegal, right? But not illegal because everything is allowed. But like the release candidate is supposed to be like not changing a lot from like the previous version, but release candidate 2 is going to be quite different from release candidate 1.
Yeah, that's because the release candidate 1 is called such because it's politically good for us to have RC1 very early in the year so that certain partners that we have can sell it as viable for inclusion in their certain operating system distributions. Let's not mention any names.
Right. Well, one thing that is important is that in release candidate 1, the ABI, the application binary interface, is frozen. So like it means that if you build wheels against Python 3.13 RC1, then those wheels will work for RC2 and so on. So if you're a library maintainer that has Python wheels and it wants to jump into the 3.13 bandwagon, then they can build wheels already against RC1 using, for instance, CI build wheel, which already allows you to build wheels for RC1, and those wheels will work on release as well, unless we really screwed up, which I hope not.
Right. So just to close on my talk, like it pretty much worked out. There were obviously unintended bugs like during live coding, so I only gather like more respect towards Dave Beasley, who is doing this thing like so naturally that it just looks easy. I managed to find most of them and fix them there, like on stage. musically, it wasn't all I anticipated, like all I planned to be, because the analog synthesizer wasn't quite in tune, and I was hearing that something is wrong.
And someone in the audio control room removed the sound from you, so you couldn't hear where you were
Yeah,
playing.
the monitors like went silent on my end, but like, let's not blame like
All
like
conspiracy.
awesome audio people that really helped me with this thing. So like that
Yeah,
doesn't
because
matter
when
so
Łukasz
much.
appeared with like 4 different like luggage,
Yes,
luggage bags.
they were a little they were a little afraid of like what is gonna happen here. So like all of this worked out. Like I just want to shout out to two things that I failed to mention on stage that were also Python. I had like a shit ton of Python. The analog synthesizer that I was using had this MIDI control module that was sending control voltage to the actual Moog synthesizers, which is called Winterbloom Soul. And that was designed and sold to me by Thea Flowers. And that's programmed in CircuitPython. So I programmed the thing that was playing actually CircuitPython. So
Really nice hardware.
Python on hardware. And then the camera view application that I showed for a split second and then covered with Ableton Live for the rest of the talk, that was PyScript.
Oh, really?
Yeah. So that was also written by me, like, using Anaconda's PyScript. So also pretty cool. So,
Damn.
yeah, like the thing is Python everywhere, right?
Right.
Okay. And then we left Prague. We returned home. I went to Japan, good, really hot and humid. Saw Mount Fuji, returned, and we went to Gliwice.
In Poland.
Oh yes, that's true. It was not super hot for me, and not
For me,
very
it was horrendous. Like I mean, I'm a Spaniard. I'm supposed to like be used to this, right? I live in the south where I was doing my PhD, but like Jesus, man.
For whatever reason, like I felt like this is livable. This is awesome now. And Pablo, no,
And
less
Łukasz
so.
was like, well, I was like, this sun is going to destroy me. It's like, well, let me tell you something. When I was in Japan, it's like, man, if you say Japan one single more time, I'm going to kill you.
Yeah. The reason why the weather comes into play was that the hotels that were in downtown Gliwice were a little bit away. I don't know, like half a kilometer or a little bit more from the actual venue, which was at Politechnika Śląska. So yeah, so we had around 100 people, which is large decrease from where PyCon Poland was before COVID. So I guess there's still some ramp up that is happening from that break for the pandemic. So there were 2 tracks, there were workshops, the venue was nice, the weather was hot. And
Just like Japan.
yeah, well, yes, compared to Japan, yes. But we found like a very cool spaghetti pizza place.
Oh yeah.
Very close to Cubis Hotel, like that. Yeah, we went there like twice in a row. It was awesome.
And I spent like a stupid amount of time trying to learn how to say thank you in Polish, which is impossible. Like, even today, I cannot do it.
So do it.
No.
You just say it.
Dziękuję.
Yeah. See. Okay. Cool.
No, but now you need to say how it's supposed to sound like.
It is supposed to sound dziękuję.
Dziękuję.
Yeah. Exactly right.
Dziękuję.
Yes. Right.
Dziękuję.
Very cool. Yeah, so we had talks, but also other people had talks and lightning talks. And there was an integration event running until 3 a.m. in the middle of the conference.
Integration event? What?
That's what it was called, like the party. Like, because,
man, I'm a physicist. Do you know what I imagine when you say an integration event?
What do you imagine?
Nothing, just people doing integrals. It's very popular. It's very popular.
Yeah.
It's very popular in that's what you do when you're at university studying physics. You do integration events with other okay. Let's go back to PyCon Poland.
Well, so the event in question was a taste of PyCon Poland of the past. You might not know this, but like back in the day, PyCon Poland was usually organized in some shoddy post-communist hotel in the middle of nowhere. And what was fun about that was that people got essentially stuck in one place with one another, eating breakfast together, eating lunch together, going to all talks together. You couldn't go to any store or cinema or restaurant after because there was nothing around the venue. So people were integrating very tightly and it felt very community forming. So that integration event like actually had that role. So I was a little disappointed that was on Saturday evening when the conference ran from Thursday, since only after people really started, kind of talking to strangers and, really.
Yeah, everybody thought Łukasz was angry, but no.
Well, but that's my secret. I'm always angry.
Oh.
No. The people that know me that
no, but that's the point. Like everybody will think that everybody else is angry because, like, it's strangers and you don't know anything, and it's like, you don't speak. I don't speak Polish. I don't even know how to say thank you.
You do though.
So,
yeah. You
anyway, so like after one of these integration events. Then we made a lot of friends. So like
Yes.
it would have been great if the rest of the conference was today instead of like.
Yeah, exactly. We need to go back. So in any case, a talk highlight that I liked in particular was a talk with this catchy title. I'm like, I just need to go there and see what's gonna happen, because the talk was called "Say No to Notebooks." Like, oh, okay, cool.
Oh, that was really good.
First of all, I agree with the sentiment, and second of all, it's just a great title. So like that was a talk by Magdalena Nowak from Stellantis, and like it actually did talk about all the dangers of having notebooks in production, right? So from having unintentionally huge notebooks size-wise, to having notebooks that rely on non-linear execution to be correct, and so on and so on. So yeah, great talk. Like when the
pedantic Pablo has something to say.
Pedantic Pablo.
You say non-linear execution, but what you really want to say is non-sequential execution, because you want to say that the cells in the notebook were executed out of order. But there is still linear because there is one after the other in a linear fashion. It's just that it's not sequential. Non-linear normally involves the rules that domain the transformation are non-linear. For instance, x plus y square is non-linear because it has one non-linear term. Like the x plus y square is not x squared plus y square, it's x squared plus y squared plus 2xy. That is the non-linear term. And that is very interesting in physics and mathematics because it's the complex behavior. So next time you want to say this, say non-sequential.
Non-linear.
Non-sequential. Did you listen to me? Okay.
In any case, great talk. When the talks are published on YouTube, you should definitely watch it. There was also a hilarious lightning talk about implementing an invisibility cloak with OpenCV by Leszek Miotk.
Oh, that was fantastic. It was in Polish and I understood everything. Like,
yeah.
He was such a...
So Leszek was like, should I give a lightning talk if it's not in English? Because some people are not going to understand it. I'm like, hey, just do what is natural to you. Like it'll turn out great. And I said it because I feel like it's true. Like you are on a Polish event, it is fair game for you to use Polish. So like just go ahead. But I didn't expect that it would be actually that entertaining. So great lightning talk there. Yeah, and the integration event like showed like in a new light Pablo to very many people, where they had like innocent physics questions, and then Pablo like unleashed his inner physicist.
Someone there, like we were like we made friends. So but they were like in my talk I mentioned like I said, photons are virtual particles, right? And they thought like it's one of those physicists that have been like switched to computer science and they don't know what they're talking about anymore. But like what they didn't know is that I was ready for a 2-hour lesson of like the wonders of Lie groups and Lie algebras and like all these things. So yeah.
To bring this into perspective, right? Like, the theory of relativity. When
this is quantum mechanics.
Yeah. When Pablo started talking about this, I realized that I misplaced my parking ticket for the car. So I started looking for it at the place where the integration event happened, and then I didn't find it. I actually managed to had an interview with the organizers, and then I managed to go back to the hotel, find the ticket, and come back to the venue, and Pablo was still talking about it. He was like,
I mean,
okay,
they were
here
listening. They were listening. So it's not like I stole the conversation. They were asking questions and stuff, and then they say, "We are sorry. You know your shit."
Yeah, so that was cool. But that wasn't the only controversial thing you said in your talk, right? Because the talk was essentially there is no Python, right?
Yeah, that was my
Python
keynote.
only exists in your mind.
Yes, very interesting.
So what was that about? What does that mean?
Well, the talk was called. Okay, so this is the thing. Okay, so the talk it plays on this beautiful. I think it's a great idea. I mean, it's not only because it was my idea, but you know, so the idea, the talk was called the ship of Theseus.
The snake of
The snake of Theseus.
Yes.
Theseus. Okay,
Theseus,
you're seeing
yes.
what is the problem. Like, I don't know how to pronounce this shit. like before the talk, I was telling Łukasz, do you know how it's called? It's called the snake of Theseus. And like he was like, what is this shit? I was like, oh, it's like this, you know, the guy who slaughtered the Minotaur, and you know, it's supposed to be pronounced
Theseus.
Okay, yes, and he's like, no, that's a lie. It's Theseus. Like, obviously, it's not like
Yeah,
that.
Pablo did not believe me, so he
Yes.
was like, Google, like,
maybe the people that thought I was full of shit for my physics stuff, like they have like some background. So I look at that Google Translate, and indeed Łukasz was right. And before my talk, I spent like 5 minutes listening to the Google Translate, like voice synthesization, like Theseus. And I started the talk, I couldn't pronounce it correctly. So also, you know, but the idea is that, you know, if Python is this thing, like the ship, and then, you know, Python changed this, and then it changed that, and then after like, you know, 10 years, it's fundamentally different, like it's the same Python anymore. And the idea is that, you know, how you make sure that Python still feels like Python, even if you change mostly everything. Like when we change the parser, how do you ensure that after such a big change, Python doesn't like become like something wild? And I made this like I think that the reason, for instance, this physics thing was linked is that I make the example that pink is a false color, like pink doesn't exist in physical reality. I mean, it sounds very groundbreaking and it's part of the idea of storytelling, but technically there are no pink photons. Like, you know, photons, they carry like a specific wavelength or a specific frequency, and the color of the photon is basically the wavelength or the frequency they have. So for instance, a wavelength of 400 nanometers or around that is blue, and 700 or 600 is reddish. And you can have photons of those particular colors, but there is no pink photon because pink doesn't appear on the visual spectrum of light, right?
Yeah.
On the visible spectrum of light. So the only way to see pink in your brain is having white light minus green.
Yeah, because white is also not a photon. It's like
Yeah,
all
it's
the frequencies.
Yes.
Yeah.
So it's very interesting because like you have, for instance, like I don't know, like I'm colorblind as well, so I may fuck up this like specific you know, facts. But you have like like what is, for instance, blue plus yellow? Like what is that color? It's like orange.
It should be green, right?
Green,
blue,
okay.
Blue and
you
yellow.
see color blindness. So green, right? So if you have a photon that is blue, and then at the same time you have a photon that is yellow, and they hit at the same time your eye, your brain creates the same effect as if a green photon is hitting your eye. Right, but it's the same effect, like it's indistinguishable, right? Modulo some reality checks. But like the interesting part is that if a bunch of photons hit your eye and it's just all the different like wavelengths minus green, your brain now creates this unique sensation that doesn't exist for any other photon called pink. So that pink never exists in physical reality, it exists only in your mind. Right, which is like, I mean, it's not the only one. Things like brown and many others also don't exist. So it's like the difference between like fundamental colors and mixed color. But it doesn't matter. Like pink is the most obvious one because the other ones are a bit tricky to explain.
So now you see what the people at the integration event had to deal with.
No.
Yeah.
Well, this is not even close, man. Like I wasn't even. I
could, for example, like just ask like a simple question, like oh, so if light is electromagnetic radiation, but electromagnetic radiation is going to some extreme lengths, right? There are super long waves and there are super short waves. Then, like, are there photons for all those lengths or no?
Yeah, of course. Yeah. Actually, I mean, for me this is not surprising, but for a lot of people it is like heat. Like when you put your oven and it is
so
like
there
heat.
are photons.
It's light. So heat is light.
Yes.
It's light of like infrared, right? So
right.
Like
infrared.
Yeah. So
you can see it
but
on
it's
cameras.
the same physical reality. So like when you have like the light that comes out of your screen.
So Bluetooth is also photons.
Yeah, it's also photons, and TV is also photons, and radio is also photons. Like all of that is the same thing as light. It's just
so white light, how many frequencies does it have?
White light is the addition of all the photons between the visible spectrum. So it's for 400 to 700 nanometers.
Okay,
Well,
I see.
maybe more on the sides, but
All right, let's get back to Python
yeah, man,
for
I
a
don't
while.
even mention
We
that.
should you should have a
SU2
physics
double covers SU3.
podcast
Yeah,
then. Yeah, exactly. But like not with me then, or mathematics podcast with
maybe you
Hood.
can act as the person who is very impressed by the physics.
Oh, like
physics
the one who asks stupid questions, unlike
Yes.
this podcast where that never happens.
Well, we can all be stupid in this podcast.
All right. So there is no Python. Python is fluid. I found it very interesting because you both covered sort of the forward-thinking part of being in the Stream Council, where you want to make sure that the changes that are allowed, right, like the kind of planning of the next version of Python, still ends up with a Python that people consider Pythonic and people consider natural to use and so on.
Which is not trivial at the time. Like you remember that when F strings were originally proposed, all the core team mostly was against that, right? Like, maybe not all the core team, but like, a lot of people were opposing, like, oh no, yet another way to format strings, and now nobody can live without them. So like, and the walrus operator, I'm sure, is still controversial, and people still hold their opinions, but like, it was not that dramatic as people were. Like,
I think the walrus operator was more dramatic than like it deserved, because F strings are way more visible as a thing, and I don't recall that much controversy on there, but there was this back and forth discussion, endless for the walrus operator, which actually caused the governance change, right? Like essentially that was the forcing function of us losing the benevolent dictator and gaining the Stream Council. Long story short, right? But you also mentioned like very practical changes to Python, like, so on a less philosophical level, how changing the parser allows now visible changes to Python. So a technological change allowed a lot of the user-facing improvements.
Yeah, like error messages and
like
match
that would not be
statements
possible with
and even
LL1.
if you don't like those, like, I mean, obviously match statements maybe like is more controversial, but I suppose everybody likes error messages. But even if you that allows us to add any of these grammar changes without breaking backwards compatibility, like with soft keywords and whatnot. So it's a technological change that allows us to like not annoy people and make Python still feel like Python and not break to code that was valid before.
One thing that you said like kind of stuck with me, which is that LL1 is this so-called toy grammar, right? That like it is not supposed to be used in real programming languages, and yet for Python it was in use until and inclusive Python 3.9. Like in 3.9, it was under a flag, like, old parser.
Python old parser.
Yes, but it was still there until 3.9. So clearly, it was good enough for Python to evolve like rather far. And you said even more that not just it was enough, but it forced some design that made Python readable, right? Because if you only have to like look up one token ahead, that means that also a human that reads Python needs to look one token ahead to understand what is going on.
Yes, and not only that, like, I mean, you could. It depends on how much pedantic Pablo you want in this answer, but like technically, LL1 is also a context-free grammar, right?
Sure.
Which means that you don't need to. Well, among other things, it means that you don't need to hold context in your mind when you are parsing code. Which means that you can just randomly scroll your file and then start reading some random line, and you can immediately make sense of what you're reading just by looking at the next word, like two words maybe. And that is unique because this is LL1 capacity. This is not true for mostly any other thing. In particular, there are languages where not only is not true, it's very not true. Like for instance, C++. Like C++ is extremely context dependent, which means that like if someone is a type or is an identifier, like who knows? Like it depends on the context. It depends what is defined or not. But in Python, that is not true. If you want really pedantic Pablo, like the fact that it has indentation and then like indentation changes a bit of the thing, like that is breaking this thing. But like that is too pedantic to bring here. But yes, that is one important thing that for a lot of people was a very important thing that they wanted to have. And when we added this new parser, which is basically LL infinite, well, it's not LL, but like it has infinite backtracking, then it's like, you in your bicycle, you're removing now the security wheels. I suppose they are called that way. But now there is no more safety like guides, right? And like now you can literally have whatever you want. But we still want that LL1 feel It's just that L1 field was still preventing us to have things that are not L1, but they still feel like Python, like parenthesize, context managers, soft keywords, etc.
Yeah, but what you're essentially saying is that we shouldn't now like go wild with soft keywords, right? And just
No.
Yeah.
Also, they are a bit slow than normal keywords, just because the parser needs to backtrack around them.
Yeah. And needs to say like, are there any other rules that fit?
Right.
Yeah.
I mean, we designed the new grammar, and every time someone changes the parser, I look at those PRs to ensure that this is true, because to make sure of this, you need to really. Like you need to analyze this a bit more theoretical than just changing the grammar file. But I make sure that the happy path is almost the time when it's going to be matched as a non as a non-variable name. And if it's a variable name, there is a very fast path that checks the equal. So it knows which one it is very fast, and it doesn't need to backtrack. So this is the backtracking distance is less than 3, right, which makes it fast.
Yeah, so I clarified some of my own thinking of what is Pythonic and what is not Pythonic in this talk. So yeah, I really enjoyed that.
And in your talk, you presented like this. I really like this, because like it's such a different talk like than the ones that you normally see. So you presented this keynote. Your keynote was about like this idea of like using WebGL and PyScript for like with Python. And I think this is great because this has only been possible recently. Now that we have PyScript and all these different versions. I was a bit critical. I think you started the talk a bit like you should have started with a bit more punch, because at some point there was a slide with like 6 different logos with just slide variations of all the possible
like
graphics.
OpenGLs, WebGLs, and so on.
Yes, OpenGL 2.0, WebGL 2.0, like GPU, WebGPU, like the different colors, and just changing the two, and everybody's like, "What's going on?" It's like we only care about this one. But apart from that, like I think it was a fantastic example of like how this is really cool, because like one of the problems, and I was actually recommending this talk to a friend of mine that is learning Python, and one of the reasons is because when you learn how to code and you're excited about it, and you immediately want to show something to your friends, right? And if you learn how to code Python, that's something is not trivial. It's going to be very impressive to the untrained eye, because like it's like a script, and you run the script and something happens. Like, but it's not immediately obvious, it's not graphical, it's not very visual. But the people that are learning web development or JavaScript, man, they can show almost anything, like super cool web pages, animation in web pages, like mini games, and JavaScript is very interactive, so you can click, things happen, and you can show very fast, like, I did this, and but like the showing something with Python is a bit more challenging. And I think this WebGL like integrations that you saw, like I think they are a very good example of how to recover the interactivity when you show Python to someone, and to get back this idea of like I made something tangible, that you can see.
So two thoughts. First of all, back in 2019, when I was invited by you to PyLondinium, I did this talk where I had this thought that I don't think Python should be synonymous to CPython forever. Like it would be great if we had like more flavors of Python depending on the context. And even then, I did mention MicroPython as one particular Python-like language, because it does have plenty of differences, small and big, with CPython, and yet it is incredibly useful in the embedded environment. And PyScript now actually allows you to either choose PyOdide, which is a true CPython 3.12 interpreter, or MicroPython, which is more limited but loads faster because it's tiny. So this is sort of showing this future where this is not exactly what you're getting when you're programming for the server or programming like machine learning, pipelines and so on. But it's still Python. It still utilizes your knowledge of how to express yourself in a programming language. The browser environment does not allow you to do everything that you can do on the desktop. Like you cannot open arbitrary files, but you can do plenty of new things. You are running within the context of the browser. So this is probably the most advanced environment that humanity ever had, because everything is available to you. WebGL was one example, but I actually ended with showing how We can also interact with hardware like a webcam, where you can actually combine both. So we can flip the image and so on and so on.
Yeah, that was very fun.
Yeah, so that is actually an application that is useful for me now. And the magic of this, and the magic of PyScript is that you can use it too now, because it lives on pyscript.com/@AMBV. And you can find this camera view application. You can press like run and run it at like right now in your Chrome for your particular webcam and see how you can drag and change the view of the camera if you need it for whatever reason. So, I don't need to tell you how to install this on your machine because you don't have to. It will just work.
But it also, I think one of the things I really enjoy about the talk is that it highlights this feeling of like tinkering, right? Because like one of the things that, like the talk didn't start with like, oh look, like I can do this and I can do that and look, it's very impressive. No, like you started drawing like vertices and like triangles and like a lot of code just to have a pink triangle, which is like, you have been doing like OpenGL by hand. It's like it's a magical moment with finally after like fuck ton of like C++, then a stupid triangle appears on the screen, and then you try to impress your friends with a pink triangle, and it's not very impressive.
Well, like the entire point was, and the talk was called like WebGL with PyScript. So it does actually achieve this goal of WebGL with just Python without any JavaScript helper libraries. We are just using WebGL APIs. Obviously, you don't want to do this normally. It's extremely verbose, but it is there in the talk. If somebody actually wants to go like low level, I show that it is perfectly possible. But we also talk about integrating with Three.js, which is a higher level API that actually allows you to do like all these things like 3D models and animation and controls like trackpad and touch in the phones and so on and so on. So, all in all, a fun talk. I did have this talk sooner than you, so I could relax sooner than you at the conference.
I was meanwhile practicing Theseus.
Yeah, I didn't have any Theseus on my talk. But you also know, like, Americans actually use a different analogy to the same thing. So they say grandfather's axe.
What?
Yeah, because the axe has the head and the handle. So like
for the same idea.
Exactly. So if you change the handle and then you change the head, like, is that still grandfather's axe?
So nobody knows how to pronounce Theseus. Theseus.
So all pronunciations are correct.
In Spanish is Teseo, and in Polish is Teseus.
Yes, exactly right. Like Łukasz.
Łukasz.
We sort of like
it's
this
not
sort of
Łukasz,
thing.
it's Łukasz.
Yeah,
with like the accent is in the second syllable.
Exactly right. Okay, so we are way past an hour point. So it's traditionally the moment where we move to more current, happenings in Python. I was very diligently ignoring everything that was happening on my vacation in August. So how about you tell us about a PR of the week?
Yeah, so I've been keeping the fort alive, emerging a lot of like pyrepl fixes. Man, it turns out that there were some bugs there. What a surprise!
What? No?
Bugs? What? Okay, so let me tell you something that happened. So when we presented pyrepl in the Python language summit at PyCon this year. So we did a talk together with Lisandros, and we were like very excited, and we discussed like we need a PEP for this, and like a lot of people had some input, and Windows support was a bit in the air at the time before Dino did his magic. But then Guido said like, "Hey Pablo, like, can you come here? Can you come here?" It's like I went there. What's up, Guido? And he was like, he had a Mac, right? And he opened the normal terminal, not the fancy iTerm or like Ghost TTY. No, just Mac
Apple terminal.
Apple terminal, like white monospace. And like so he opened the REPL, and then he made the terminal super tiny. And then he started putting characters in the REPL, like whatever, until they touched the right side of the terminal. And then he looked at me and he was like, "What do you think it will happen when I type a new letter?" And man, the answer to this is always like, it's going to blow up. Like I don't know how.
There's something gonna be wrong.
But man, like I was really surprised. Do you know what happened?
So now I know because you showed me. I wouldn't expect. So
yes, I saw him.
There were
He was
two separate
like,
bugs.
"What?"
Yeah, there were two separate problems.
Yes, well, at the time it was only one. So right now there were two. So one of them is that when this happens, what is supposed to happen is that the text wraps around, and then it's like instead of you don't see in the text that because it doesn't fit any more characters, it goes to the next line. Yeah. It's not really. It's called a virtual new line because not really a new line because you are still in the same line, but just because the terminal doesn't fit it, then it displays as two lines.
It's wrapping the words.
Exactly.
Yes.
But the way it shows you this that is not a real new line is that the three chevrons or two chevrons or whatever they are at the beginning of the line, they don't appear in the next one. Like there is no more input. It's just the same line, and there is this slash character at the right backslash. Sorry, mentioning like okay, this is just a virtual new line. Okay. So what is supposed to happen is that you press a new key and then the backslash character appears on the far right, and then the new key and the old one that now is substituted by the backslash character appears on the next line, and then no chevrons. So what was happening is just below, to the far right part of the terminal, just below that, the text start appearing on the right and going
from the right
to the left. So like it starts being completed the other way. So instead of from left to right, from right to left, until it reaches some mysterious point, in which case it starts like wrapping around, and then it starts appearing in the next line, and then the chevrons start to appear from the left. Yeah, man, like what a wild ride. And then so Guido showed me this, and he looked at me, and I was like, okay, we will fix it. We will fix it. But we didn't, unfortunately. I mean, until today, because we have more serious issues. But then some person complained that this happens. Not when you do the terminal very small, but when you paste like a very long line, and then it does this weird shit. Like it's just really annoying. The thing is that we were supposed to handle this, and this only happened in Apple terminal. Like any other terminal, like iTerm or like Windows terminal, like even on Windows, man, like what a wild land is Windows. So even on Windows, it works. Even on CMD.exe, because Dino did very good work.
Exactly.
But only in the Apple terminal. Man, and I was like puzzled. And there is we use Termius, and there is a Termius thing that is supposed to handle this Termius or blah 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 whatever. Like that means like please wrap around, like don't wrap around, I will do it, like because PyRepl does it by itself. Well, it turns out that long story short, Apple terminal, because Apple, thanks Apple, I suppose, Team Apple was decided that Apple terminal is going to ignore that shit. Like please wrap around. No, we don't do that here. So they have a very specific way to ask for this. So you can input something like tiput like it's a bunch of consonants together, and if you tiput, then it says like, please stop wrapping around, I will do it for you, and then it works. But the problem is that I cannot make the REPL tiput
for every terminal.
Yeah, for every terminal. That's fucking annoying. So the way we're doing right now is that it turns out that when you do, so I opened the C code of tiput, and it turns out that what that is doing is outputting a specific ANSI command for doing the same thing. So it's just a bunch of bytes that are printed for doing the same thing. And normally that is handled by Termius, but in this case you need to do it by hand. So now there is this conditional that says, if Mr. Apple terminal only, then please now tiput, and then and then it deactivates this stupid behavior that nobody wants. And then the rest of PyRepl works nicely and it wraps around. So you can like paste it again. And then when we finish PyRepl, it undoes the and that's it. That's the fix.
We were very proud to get rid of the readline dependency, but it turns out like readline has like 30 years of workarounds for weird behavior.
Then when I knew about this, I look at readline and they do a bunch of, they do it just by chance. They don't handle specifically upper terminal.
Oh.
No, there is like, but they say some old terminals in IBM, like they misbehave, so they send the ASCII code. They don't do them to put. But the ASCII code is the same one, so they activate it on top.
Oh, but they always send it?
Yes.
For all terminals?
Yes.
Okay, so it seems
I say just too far, maybe no. I think they do it. They check. So there is a ANSI code to check a bunch of capabilities, or there is some API to check terminal capabilities, and then on some conditions, and then they check those, and then they all put it on specific situations. But in my in the 30 seconds I dedicated to this particular task, I think it's all of them, because like I couldn't find any reason for modern terminals that it was not being output. So I don't know. I mean, they are not using Termius there, so they are doing it by hand.
All right. In any case, an impressive bug fix. So another thing that we need to cover, and you're gonna know more about this than me this time around, is what's
going on
in CPython.
Why? Why are I going to know more about you?
Let's start with new features and enhancements when I was gone.
Well, what about DH99108? This is a big ass PR, man. Wow.
Right, yes.
So there is this HashLib. Tell us what HashLib is doing.
Well, HashLib allows us to calculate hashes of byte streams. So you can just provide it bytes and say, I want an SHA-1 hash of this and this and this, update, and then hex digest or whatever else.
Right. It sounds very useful. I'm sure that there is a lot of stuff that is
useful. A lot of usefulness there. And some of those hashes are more complicated than MD5 and SHA-1, like Blake 2, right?
Right, yes, very annoying. So we actually had like an entire handwritten implementation of Blake 2. And this gentleman called Jonathan Protsenko, I think it's pronounced that way. So he replaced this handwritten Blake 2 implementation with HACL Blake 2 and Blake 2 2S, which is like a library, right? And
so it's kind of weird because it's called like HACL star or asterisk. I don't know, like is that pronounced or not? Like when you're reading it, I don't know, but like it's everywhere. Like if you look at it, like
people doing cryptography are like stupid idiots. It's pronounced.
I don't know, but like it's there. Like every time you see it, it's like HACL star. There's like literally like an
there is something going on. Maybe it's like A star. Well, anyway, so it's like a code written by professionals. I mean, not that the previous code. Maybe I don't know who wrote the previous code, but clearly, people that know more than us about this was not happy with that, and now we vendor that library, I think, or part of that library. And this actually improves performance and security because it's a battle-proof implementation of this, and people that do cryptography or security, like they're using this all the time, so that's quite important. Quite a big PR, 55 file change.
Wow.
Most of them were removed from the previous implementation and added. But
okay, I blinked and was gone for 1 month, and Barney Gale in that time added a bunch of methods to pathlib, which I always wanted to have too, so I'm very happy they're there now. So you have copy, move, and delete on path. So that essentially sort of slowly removes the need for util, I guess, since like it allows to do those things directly on path objects. So that is awesome. Like I like this.
Oh, you know why it's called HACL star?
I know.
Because it's a cryptographic library written in F star.
Oh. And HA stands for high assurance, I see.
Yes.
That is very cool.
High assurance cryptographic library. That's HACL. Yes. And it has one argument called Cha-Cha-20. Look at that in Spanish. It has meaning.
Okay.
Yeah. Okay. Cool. So another of the cool things that we have new is that we add a new CAPI function called PyEther next item. Wow, I'm very like we didn't have this.
Yeah, I was also surprised.
Wow, this is a bit ridiculous. So this is by Erlen, core developer Erlen E. Aslan, and this is a CAPI basically to grab an iterable object and return the next item. So this is basically the API provides basically a more convenient way to handle iterations for C extensions. I'm very amazed that we don't have this. Maybe we have a underscore by either next item or something.
Yeah. This looks more high level. I like it.
Right. Yeah. I mean, this is so obvious that I'm very amazed. Surprisingly, a lot of file change for this. So nice. I'm pretty sure this is a nice change.
And Victor Sinner was also busy adding pylong from int64 and pylong as int64. So that's interesting. So new CAPI functions for converting between int64 type.
Man, I needed this. I needed this for memory things. I don't know.
Memory profiler.
Yes, and there is a moment when we are converting from this and doing it by hand is very annoying. So yeah.
Yeah, very cool. So now everybody's gonna have this in, I guess, Python 3.14 because all those new features, they are not going to land in Python 3.13 next month. Like we have to remember those things are only kind of landing in Python.
Python.
Yes, 3.14 for next year. Okay, so let's see how things got faster.
Well, by our one and only Bram Booker in GH118093. I love that we are saying these things like it matters. Like nobody's. Well, maybe someone is looking at it. So Bram Booker added a bunch of like new bytecode instructions, particularly call alloc and enter init. So this is all this tier 2 interpreter bytecode that we discussed in previous Python episodes. Maybe we should do an episode about the entire tier 2, because like we are mentioning it all the time. We have mentioned how it works, but this is just already complex enough that maybe we should dedicate an entire episode.
Yeah, we just had a guest from that team, but we were talking about other stuff. But tier 2,
Well, anyway, this commit basically optimized the call alloc and enter init, the opcode for tier 2, and the idea is to make it like work with the Git compiler, and improving like the performance and object instantiation.
Right. Mark Shannon was also very busy, adding tier 2 support. Speaking of tier 2, for binary subscription Git item. That looks also like a larger change. So yes, that's GH118095, if anybody actually looks at those numbers.
Then we have another from Mark Shannon. Mark Shannon, what a man! So he removed the check eval breaker macro, which was this thing that was allowing the the ceval loop to stop for things like garbage collection and signal handling and whatnot. And basically it refactors all the code. And I had to change that code to move the garbage collector check to the eval breaker. And man, that was messy. Mm-hmm. So this change makes everything a bit more fast, even if it's sub 1% performance. But there was a bunch of unnecessary checks, which I really look forward because of the extra clarity, because that code was it was non-clear, it was surprisingly annoying to change and to ensure that was being handled. So that's nice.
All right.
By the way, please. So we, CPYTHON is a very popular project, right?
It is.
And GitHub does this stupid thing when, sorry, GitHubbers, but I think it's a bit stupid that they handle, but I don't know, maybe it's not, but they use the same number for PRs and issues.
Yes, those are likely the same objects in the database.
Yeah. Well, implementation detail leaking. Okay. Well, so Python has a lot. And recently we were very close to issue or PR number 1, 2, 3, 4, 5, 6. Right? What happened, Łukasz?
There was a spammer who created a new account only for this and created just spamming issues or PRs.
2 issues, I think, for the ones that come before. So 1, 2, 3, 4, 5, 4, 5, 5, and 5, 6. Please don't do that. Don't do that. Boo.
Yes.
That's not.
Don't steal awesome numbers from hardworking contributors. 1, 2, 3, 4, 5, 6. Come on, it was a nice number.
Yes, and that is cool when you don't go looking for it and then you get a nice number. I mean, it makes sound silly, but come on. Yeah. Well, don't do that.
Yes, don't do that.
Exactly. Okay, right. So in GH122417. So we have Sam Gross.
Yes.
I think I have heard about Sam Gross.
Yeah, I guess he works at Meta, probably.
Yeah, maybe he has a lot of things to do at the same time.
Yes, in parallel.
Yeah, exactly. So, Gil. So he, in this particular PR, he implemented a per thread heap object ref count. Quite important. quite important.
Yep.
Yeah, so the idea of this is basically adding a system for heap types, which are the Python classes basically represented in C that are instantiated dynamically, so they don't live in the static memory of the object, which is mostly of the types, or we're trying to move all of them to this. And the idea is that this reduces contention in multi-threaded scenarios, so basically it speeds up the thing and makes it more correct.
Yeah, very cool. We like to see the speed of free threading Python to actually get better and not worse. So yeah, good.
Nice. Well done.
Yes, and Sir Histrochaka optimized pickling by name objects without dunder module. So that's good. I didn't even think about this sort of particular case where you had objects that didn't really know which module they come from, but apparently now they're faster. So that's also great to see. This was also not something that we just come up with by ourselves. This is reported to us, so Probably somebody's going to be now happy by having
There's a
faster
single
Python.
thumbs up emoji on the, on the VR.
Yeah, that's what I'm saying.
Cool.
So now, things that got fixed. So likely those are things that are also going to be fixed in 3.13 release candidate 2.
Well, one of the important ones by Sergey Storchaka, which this guy is like fantastic. Like he fixed all the things. So he fixed ON square complexity in parsing in the cookies in the HTML library that has backlashes, which is quite important because you can make like denial of service attacks with that and things like that.
Right.
That has a CVE actually.
Yes, that is a CVE. We're going to be releasing security releases next week for
CVE
all the
2024
Pythons.
2024 C592.
Yes, like this is maybe, possibly, hopefully gonna be the last release of Python 3.8 ever. I probably just jinxed it. Well, end of life is coming in October. So yeah, like unless we need another release before that, the release next week might be the last one. We'll see. Maybe I jinxed it. Yeah. So SamGrows also fixed free threading memory leaks at shutdown. So interestingly, you can shut down the interpreter and then continue doing things. So
well, I mean, you can reinitialize the interpreter.
Yes, exactly.
A lot of people that are embedding Python do this, like
Yes.
in Blender, for instance.
Right. So Python itself, like when you're just running the Python process that is provided by the Python project or compile your own Python, like that is not a concern that you're going to be having. But if you're embedding Python, yeah, entirely correct. So in this case, memory
use of
leaks
interpreter
used to occur in the free threaded Python. So if you use sub-interpreters and you are shutting them down and you're creating them, that had the same condition for the memory leak.
No, because I think these are global objects that
Yeah,
are immortal
I
and
thought
things
so.
like that. But there is a non-trivial intersection between the concepts because there is the immortal objects that are like now there is an entanglement there of like what objects are being immortalized per interpreter or like between all interpreters. I think in this particular case this is like the global object.
But it's
set.
less complex than quantum entanglement. So
Or the
it's
fact
fine.
that yeah.
Not triggered? No, not triggered.
I was going to say something cool, but like, the double cover of SO3. Do you know what is that?
What?
You know what is the double cover or the universal cover of SO3? SU2 is the universal cover of SO3. We will talk about that another day.
Okay, so getting to documentation, cleanups, and so on, we are reaching the final stage of Python 3.13 preparation. So everybody's going to be looking at the what's new document. And Adam Turner and others in multiple commits made many improvements and updates to the documentation there in what's new. So very happy to see this.
Which is very important because like, you know what happens when we are very close to 3.13 release, right? All the YouTubers in the planet go to the what's new and they use that to create their videos of like, what's new in Python 3.13?
Some already appeared. Some have more than 47 views. Really?
Wow. So yes, I mean, the what's new is quite important. Normally the release managers are the ones creating the document, but now that we have such a good documentation team, so shout out to all the people working on documentation. So this looks very sharp. And Sergey Stochaka again. Like I see a pattern here. Łukasz.
Yes, Sergey is very active. One of the developers in residence.
We thought he was a robot because nobody has seen Sergey before.
I thought this was like an inside joke, and it was just an alias to like other core developers like Guido or Tim.
It's a team of people.
Yeah, exactly. But yeah.
No, it's real. He's fixing everything. So
Yes.
he cleaned up some deep recursion-guarding code in the compiler, which simplifies basically the code. This is the code that is used so the compiler doesn't blow up because it needs to compile some super nested if conditional that some machine learning LLM generated or something.
Right. Cool. And finally, let me just say that we're adding support for new platforms like iOS and Android. So now we actually have the capability, finally, to run a test suite on Android emulator devices, thanks to Malcolm Smith. So that is also great to see. Yeah, like plenty of changes when I wasn't around.
Well, if we have not mentioned your change, we have been out one entire month. So
Yeah, exactly. So apologies if we haven't. We're going to be looking closer right now. Starting essentially tomorrow, I'm back at work. And in September, we're going to be seeing each other again in real time. Just like now in Poznań, we're going to
The core developer sprint. Wow, in Seattle, but not Seattle. What is their city?
in Bellevue, Washington.
Bellevue.
Yeah, and I'm going to go there. Actually, going to Carl Meyer's at Bellingham, and then the core sprint at the Meta office in Bellevue, and then to visit Dusty Phillips in New Brunswick. So a Python adjacent trip, like to many places. But yeah, the core sprint, an entire week of a group of Python core developers working. Yes, working on CPython exclusively. We like sprints that are kind of tethered to a conference like PyCon US or EuroPython, but they are not exactly the same as being fresh and ready and meeting at a quiet place and hacking on a new feature or bug fixes or performance improvements with other people in real time. So those core development sprint weeks tend to be really useful, really like them. So thanks for Meta for organizing and sponsoring this year. We're going to meet in their offices.
But Łukasz, you know, you know what this means, right?
No.
Our first episode was in the core dev sprint of past year, which means that this is our anniversary. Wow!
So we're reaching our anniversary. Was there gonna is there gonna be cake or is it a lie?
It's all a lie.
Is the cake a lie?
Oh, we don't have enough money for a cake.
But maybe we're gonna organize something. I'm hearing we're gonna be recording an episode of a different podcast in Bellevue.
The changelog.
Yeah.
Really cool.
So yeah, we'll see how that goes.
Yeah, we can celebrate our birthday by doing more podcasts.
Okay, a strong comeback with an episode over 90 minutes long.
As always.
After 2 months.
Sorry, but not sorry.
All right, and now, really, hopefully, truly, see you in 2 weeks.
See you in 2 weeks.